This is for further maths. We're going to look at exercise 17F, which has to do with volumes, surface areas of 3D shapes. So we'll have a look at question 1C first. So 1C, if it says cross-sectional area is 2.8 centimeters squared, and the height 6.2, find the volume of each of these shapes. So I just want to go through what a prism is. Okay, so a prism is a shape such that where if you cut the cross section of the shape any point, so if I use a knife and cut it here, cut it there, cut it there, cut it there, cut it there, each of the shapes I get as a result will be the same. So you'll still get a slice of a circle, okay? The same circle. So here it's the same thing. This, you can think of this as a slice of cheese. If I cut this horizontally, then I'll get a cheese shape that looks like this all the time, okay? So you always get that cheese shape, and so it'll be exactly the same size. So that's what the cross-section is. So the volume of a prism is the area of the cross-section times the height, okay? So here, the area of the cross-section is actually the triangle here up the top. It's the cheese, and the height is this. This is the height. Okay, so the volume is given by the cross-section area times the height. So volume equals cross-sectional area times the height. So the cross-sectional area they're given to us is 2.8, and the height is 6.2. So just go 2.8 times 6.2, and you should get your answer. They've actually done the hard work for us. Usually you have to actually physically calculate what the area is. Okay, so 6.8 times 2.8 times 6.2 gives you 17.36 centimeters. 17.36. It's not centimeters, it's centimeters cubed because this is a volume. Okay, so be really careful with units. In the SAC or test, if you get the units wrong, you'll lose a mark, unfortunately. Okay, so don't lose that mark. You've done all the hard work. Get your details right. Okay, we'll have a look at question 7 as well. So for the prism here shown, again, it's like a cheese. Okay, if I cut this like vertically, I always get that triangle shape like this. Okay, so we're trying to find the volume. The volume is the cross section, which is here, times the height, which is or the length, height or length. It doesn't matter. It's just how far the cross section goes. So it goes 0.5 meters. Okay, so volume. Oops, let's go back here. Volume is given by the cross-sectional area times the height. So the cross-sectional area, this is a triangle. Triangle has an area of half times base times height. Half times base, my base is 3, this is a right angle triangle, and the height is 2. Okay, 2. So this is my cross-sectional area, whatever that is, and I need to multiply this by the height. So the height has to be 0.5. So 0.5. Okay, so you can work that out on the CAS. 0.5 times 3 times 2 times 0.5. 1.5, so the area is 1.5 meters. No, not 1.5 meters. 1.5 meters cubed. Okay. So volume. Now we want to find the total surface area in meters squared. Okay. Now surface area is how much this has been, or how much area is actually exposed to the air. Okay. So what's actually in contact with the air? So if you were to redraw that shape, you get two triangles that's exposed to the air, so the front here and the back there. This surface here, so the very top surface, which will be a rectangle. So you got a triangle, 3, 2, 3, 2, rectangle at the top, which is 0.5. Okay, that's a bit tricky. We know this is 0.5, but what is this length? Okay, now this is where you have to use Pythagoras. So if you want to figure out that length, we've got a triangle. We actually need to find what that length is. So if we use Pythagoras, we're solving for the longer side. So that's 2, that's 3. If that, we'll call that x. X would equal the square root of 2 squared plus 3 squared. So we'll do it on calculator. 2 squared plus 3 squared. And the square root of that. Okay, so 2 squared, square root of 2 squared plus 3 squared. 2 squared plus 3 squared. 3.6056. So let's go back. 3.6056. X equals 3.6056. Okay, so we've got 2 sides and a rectangle. We also have the back. The back is just a small rectangle. It's 2 times 0.5, and we've got the bottom. The bottom is another rectangle. It's 3 times 3 and 0.5. So you simply add all the areas together to get what your total surface area is. So surface area is all the faces which are facing the air. So we got 2 triangles. So let's work that out. 2 triangles here and here. So it's 2 triangles. So 2 times half times base times height. Base is 3, height is 2, plus the area of the rectangle here. So 3.6056 times 0.5 plus the rectangle down below. 2 times 0.5 plus the other rectangle, this rectangle, the last rectangle. So 3 times 0.5. Let's see what we get. Okay, as long as you show your calculation and I can follow what you've done, you'll get the marks. But make sure you show some working. Okay, even if you're having to draw shapes, make sure you show some working. Okay, so let's do this. We'll go 2 times 0.5 times 3 times 2 plus 3.06. So I'm just going to use a full value just so that I'm careful enough. Times 0.5 plus 2 times 0.5 plus 3 times 0.5. Okay. So we should get 10.30. So there is 10.30 meters squared. Okay. So hopefully that helps. It gives you an idea of how to approach surface area questions. You're just gonna account for each of the faces and work out like the value of each of them. Hopefully that helps.